All right, let's do this thing. We are officially live. I'll let the internets know. We're going to fuck around with some network code in C and C++ today. Someone jokingly or seriously suggests, you should build this in Rust. And I'm like, yeah, gross. Rust is so hard. You have to push a boulder uphill just to walk one step in Rust, almost, if you do it correctly. All right, let's see where the chat's at. So I have my chat window open. Greetings, viewer. Hopefully the stream quality stays good. I think I'm at no risk of doxing myself either because I'm only sharing the terminal window. Should put some music on the jam. But I guess before I get started, I'll give a little bit of a rundown on what it is that we're actually building here. It says Botnet in the title, so I'm certainly fed baiting a little bit, but like there's this book by this group called VX Underground. They have a website and a Twitter and all that, and very interesting content. For those who don't know what they're all about, I highly recommend you check them out. It'll open your eyes to a lot. So, towards the end of their first book, VX Underground, Black Mass. See if y'all can see that shit. Yeah. At the end of this book, VX Underground, Black Mass, Volume 1, there's a really fun little article or chapter or whatever you want to call it called The RedKing HiveMind, written by Bot, spelled B0T. I'm not going to read the whole thing, but I will read the introduction. Greetings, Steven Strogatz, CRW, and FOUL. RedKing is a project to create a decentralized, autonomous botnet that is capable of code evolution. Though I did not accomplish all of my goals in this write-up, I will continue to work on this project until it is useful. This project is written in Kotlin and simulations are written in Java. A peer-to-peer HiveMind. RedKing is an attempt to create a network that can operate without the need for any kind of command and control server or supernodes in a peer-to-peer network. Additionally, I describe a relatively simple trick to allow the network of machines to resolve an arbitrary optimization problem provided by the bot master. In essence, the goal is to create a decentralized HiveMind that is difficult to control or stop. Motivation. Better analysis of program behavior has been a major improvement of security tools in recent years, be it through Splunk, a monitoring tool like OS Query, or some special logic coded into an agent. Behavioral analysis has and will continue to become more advanced. Microsoft, CrowdStrike, SentinelOne, and others will continue to develop new features, which will eventually converge on watching the standard user's behavior at all times. This is a feature today, but it's not hard to see how it may end up being a social issue tomorrow. What if a company or government is alerted just because you're doing something considered unusual on your computer? It's easy to laugh at this now, but Microsoft, for example, is getting more advanced in these capabilities. Defender is very hard to completely remove from Windows. Don't kid yourself that Apple is better. Google Location D, they have no problem getting more info from your machine if it makes them money. Is this the year of the Linux desktop? We need to subvert this potential threat by being a step ahead. Ideally, a decentralized swarm that can manage itself to counteract this threat. So, that's the introduction to the RedKing HiveMind, right? So the idea seems pretty interesting and straightforward once you have an idea. At first, I thought I understood, and I had this idea for mapping using their virtual addressing space technique, or idea, I should say, where every node in the network is assigned a value from 0 to 1 floating point, right? So a real number, as in not an integer, but a decimal, 0.565, 0.123, etc. type number, right? And this essentially acts as a virtual addressing space. So the idea is that you don't actively, well, I'm still working on the implementation for this, right? But the idea is that you manage the relationships and the connections using virtual address spaces. And this is supposed to make it difficult to actually figure out how many machines and which machines are actually connected to the network as a whole. So it's a really cool idea. And I thought to myself, I hate Java. And I don't know Kotlin, and I'm not going to learn it. But I do know C++ and C. And in the best case scenario, if someone were to actually have a botnet and were able to like get code on the machines and run it and stuff, ideally everything is like running the same architecture. Ideally everything is running the same operating system. But it would totally be possible to like distribute binaries for different architectures, things like that. Be able to like have copies of the botnet client like stored in the botnet itself, so that, you know, let's say I'm an evil hacker and I infect a machine and I want to pull down my botnet client for Windows. Well, I should be able to like query the botnet, right? Like be able to like throw out almost like an API request to a particular address that is known ahead of time. It doesn't have to be a central node in the server or a central node in the network so much as like any node in the network, really, because ideally every node is able to accept connections from other potential new nodes that want to spin up, right? This is how we would effectively grow the network. So what do I have so far? So I've got something that's, I believe, pushed up on GitHub, and I'll start like working on the repository over time. And I had the idea last night, and I decided, okay, today I'm going to sit down and actually take a break from game development and work on this thing instead. So we're in the process of building a generic client server model where every node in the network is potentially both a client and a server. And we're in the process of getting like the very beginnings of it. This barely works or does anything at all right now, but it does build and run. And we do have an ability to spin up a beginning central, because every node, every network has to start with one node at least, right? So when you first run the program, the first initial server sits and waits for connections. So let's take a look at the main, right? Like, based on how you run it, if you run it with less than 3 arguments, so in other words, like just 2, oops. So if, let's see, if argc is not equal to 3, let's just do some basic error checking here. Wait, let's check usage. If argc is not equal to 2 or argc is not equal to 3, then we want to all right, so there we check usage. We do it a little bit more intelligently. Let's take a look at the main. So run a program with 2 arguments. We run the server. So the first thing that would happen is the first node in the network spins up and waits for a connection, right? Let's do that right now. So the first thing it does is it tells us running as primary server on port 8080. So you can specify the port on the command line. And we assign a randomly generated virtual address to this node. The next thing that would happen down here is we would attempt to connect to that port and IP address that we know ahead of time. So if we know that we have a node running on a particular list of IP addresses, then ideally we can connect to that node and have information about the new node propagate through the network. We're not really there yet, but this is the direction that we're heading in. So in order to begin this process, when the node first attempts to connect to our server, the connecting node is going to pass some information off. Okay, so in this case, the server failed to connect back to the connecting node, so we have to run it again. And actually, part of the cleanup that I have to do today is, or during the stream, is properly handle the cases where we fail to connect and not actively store the information about that node because the connection fails at the moment. So these are failures. There we go. That's a success. The reason I know it's a success is because I tell the server to actually send back hello world to the client that's connecting to it. What happens in the code during do server, this is very typical for POSIX networking code, anything like socket oriented networking. There's a lot of setup involved, but it's pretty straightforward once you kind of understand the pattern. Right, just better organization there. We print out that the primary server is running on a certain port. We print out the primary server's virtual address. Then we connect, or we create a new socket, and we set a socket option on it so that we don't have such a big issue with the unbinding after the program dies. We bind the socket so that the kernel knows it's in use, and then we listen on that socket. We set the socket to listen, rather. And then while true, so for all eternity, and this will be something that the other sockets do, and I'm going to end up having to set up threads in order to do this more properly so that we don't have like hangs. It's possible that we may not necessarily want threads, but so while true, we wait for a connection, and then if there's an accept error, we return 1 to kill the program. And at this point, the connection's been successful from the node, and the server reads whatever the client sends over, which the client is set up to send over a blob data type that I've defined up here. A blob simply at the moment consists of a virtual address and a port. It's very specific. So we grab that blob, it has a virtual address and a port, and then we get peer name on the connection in order to get the connecting IP address. And then we can take the information from that peer address and print it out. So over here, we have connecting my local IP address and the local port that's coming from, and the virtual address that came back with it. As so actually, we want to print out the blob port. Let's rerun that server. Okay, so the port that we get in the blob is the port that the client has opened. That's randomly selected from like 8000 to 65535. And I'm going to have to build things that like make for changing port to be a bit flexible. Because I can imagine a scenario where like you've previously set up like a, well, I can think of situations where you have information about a particular node that you want to connect to and its port, and someone on the network puts up a firewall rule to block outgoing connections to that port or incoming connections to another port. So the node on that machine would have to be able to recognize a connection cut and then be able to reestablish a connection by connecting or opening itself up on a different port and then distributing that information to the rest of the network. So it would have to have information ahead of time about like a list of peers that it would be able to connect to. And if it had previously successfully connected, then it should have some information about nodes that it would be able to connect to, right? So that's what we would want, is to be able to dynamically update connection state and changes over time. So what happens if I were to run the client again and connect again as if we had a second node, right? So we're able to get like an updated list of peers. And so here's an example of what happens when the server fails to connect to the client. So back over and here's where we actually, once the connection is established from the connecting node to the server then attempts to connect back to the connecting node, the client, in order to give us like an idea of like whether or not we have back and forth communication. So I haven't figured out why in some instances, even after 10, 20 connection attempts, it might fail to connect back to a client that's connecting and has an open port waiting. So in situations like this, we would not want to actually update the information about the neighbor because we failed to connect. So only if the write is successful do we want to actually update the information about the neighbors and print it out. So let's rerun the server. Now let's reconnect a new node to our server. Oh, it's complaining about one of the, let's see, 197. Oh, let's see. Oh, it shouldn't even do this. Oh, whoops. I meant to run this. There we go. So that's an error. There we go. Okay. So that was like an example of 2 failed connection attempts and then a successful connection attempt. So at this point, the client should realistically turn into a server itself. But before we can really get to that point, since we have established that we're able to get the server to send a message back to the client needs to have a useful message, right? Because we're able to get the server to print out its own connecting neighbors, but we need to also update the client in order to know information about the server. So the server realistically needs to send back its own blob. So let's do that. Where is port defined at? Oh. Okay. So that's half of it, right? We're now writing a blob, a binary data thingy to the client. So the client now needs to handle this. Let's see. Client wait for messages on port. So I'm attempting to start pulling a lot of this into individual functions. There's a lot of reorganizing that has to be done. It's definitely not all happening today. This is a massive project that I have embarked on as a side thing to my game dev. So let me check the chat real quick. Hi Octo, hell yeah. That's what's up. I'm gonna snooze the ad break. I got like 8 minutes or some shit. There we are. Okay. So client wait for messages on port. So nice. We've got like a delivery or something. Okay, so here we don't want to actually read into a buffer. We want to read into a blob type temp blob. So at this point, to confirm what we have, we should be able to just see out the blob as a whole. Oh no, it will not let me do that. So I'm gonna have to print out the individual elements of the blob, and that's fine. Do server doesn't use argc, but now it does. See, 180 is unused. All right, no warnings. Hell yeah. All right. Let's get this virtual address exchange underway. We're listening on port 8080, and we're going to connect. And it looks like the exchange occurred. So there's the servers virtual address, and here it is being received by the client, as well as what port it was. Here, let me go ask these dogs to be quiet. 1 second. Those dogs get barking and grandma starts yelling. So, good times. Where was I? So the address is, so this is the address for the client, and it gets exchanged with the server. The server successfully adds it to its neighbor's map. So we're going to want to do the same thing with our clients. So let's do clients. Wait for messages on ports. But at this point, we want to update our neighbors list. And then print my neighbors. Oh, damn. One thing I dislike about ZSH is the shared history thing. I want every fucking window, every shell session to have its own history. Okay. Now, at this point, it would need to turn into a server that can sit and wait for new connections. And I see grandma moving, so gosh, I have to get up again. Be right back. Okay. I was saying that what we want to happen next is that once the client receives the message from the main server that it connects to, that we want to turn the client into a server as well. Now, if we do server at this point, I think we would actually want to pass in the server port as a parameter here, because then we'd be able to just call do server at the end of the client. And it would already have information about the like they would already have information about each other basically. So I think that would make sense, right? So that would make sense. The server will run forever. Because once it's running as a server, I mean, it just literally waits for connections and adds them. Um, because all of the advanced stuff about like updating the nodes in the network with information is going to come later. So our goal today here is really to get 3 nodes connected and aware of each other. First, we run a starter node that has no nodes that it connects to, so it just sits and waits as a server. And subsequent client connections will connect, exchange a message with the server, receive it, and then we want to turn that client into a server. Not with port though. Um, no, this is the wrong function also. Wait, no, this is correct. Client wait for messages on port does this, and then we want to do server on port to open. Or better yet, because it would have to reopen it at this point, right? Okay. Okay. Um, so the first node ran as a server and it received a neighbor. Um, and we got that information about that neighbor right here. Um, now we should be able to actually connect to this one on this port. So we're going to need yet another window open. Okay, we're already in the correct folder. So all we have to do is build /RedKing. Can we do 000036395? Hell yeah. But it failed to connect, so that's okay. That's okay. Um, hell, we got it. So the first node, the primary server over here, started running and it waited for a connection from the first client node over here. The client turned into a server itself, and then we spun up a third node and connected to the second client, which became a server. So that first client now has information about the initial server that it connected to, as well as the node that connected to it. Now, this server, or rather this client, does not have any knowledge of this server over here, this node, right? So one of the next big goals and big steps in this whole process, which I should definitely add in the to-do, so when when this event happens, right? When the first node, or rather when the third node connects to the second node needs to inform its own neighbors that it has a new neighbor itself. Or this neighbor, this first node needs to ask node 2, what's your neighbors list, right? Because then this first node and this third node would have information enough to connect to each other, right? Because if we know that this server is running on this port, right? And we know this server is running on this port, right? Actually, see, this is incorrect. What we need, this is not the correct value here. This actually needs to be 80/80. So that's something to also fix. But you can see how we just about have enough information to be able to exchange and synchronize all three nodes. And I've got to go again because grandma's up and moving. So this will probably be a pretty short stream. Hopefully, I've given some people some interesting ideas here. I'll try to make a long form video about this content as I continue working on it because I think this is really an interesting project and I want to keep at it. But grandma's got a really bad habit of around this time of day getting up and moving and not really giving me a whole lot of free time to actually sit here and work on things. It's one reason that the videos have been kind of a little bit more productive rather than actually attempting to live stream. But I'm doing my best here. I don't want to leave her, unattended. So let me check on her real quick. Okay. Sorry for the delay. What was I doing? I totally forgot. Um, what was I explaining? What was I talking about? What exactly was going on? Um, believe I was working on this RedKing HiveMind stuff. So that's right. We got a third node connected, and we want to exchange information between nodes. Um, we want let's see. That's right. So this right here, that needs to be here. So when we add a particular blob, client wait for messages, do server. So do server is where this little bug is at. Or wait, no. Yes. Is that initial server. Sends back some info. Oh no. Okay, whoops. Blob port. Wait. Okay, so let's rerun this. So here's the initial server. And here's the first connect. Um, there we go. So this is the incorrect neighbor. So the client receives the blob from the oh no, so it is temp blob.port. So that's what we want to actually put in here. Okay. That should be fixed now. I do recognize that there's going to be a lot of opportunity for automating the testing of this kind of thing too. All right, so we failed to connect there. There we go. So we have the correct port coming back as far as which port to connect on for the main server. Now that we have that, we can connect on 46.323. Boom. Uh-oh. 207. Let's see. 207. Bind error. Oh, this is on do server. Okay, so interesting. All right, so we're going to do this again. All right, so 38969. Boom. Okay, got it. No errors. So we are informed of the fact that 38969 is the one that we're connected. We could even do a fourth one now. So we'd have like effectively a chain of connections going. So let's do build RedKing 0000 and then 30068. And we should see connection attempts in this window. All right, so we failed to connect, failed to connect, failed to connect, failed to connect. Boom. All right, so node 4 knows about node 3. Node 3 knows about node 4, or rather, wait. All right, so node 1 knows about node 2. Node 2 knows about node 1 and node 3. And node 4 knows about node 3. My virtual address right here shows up here. So we connected there. And then 0038969. That's this local one. That's us. Wait. We shouldn't be added to our own list of client or neighbors, right? That doesn't seem correct. Okay, so this is for the server. Um, oh, there we go. Address already in use. Yeah, we need to be able to handle these sorts of connection issues a lot more cleanly. So I think what's in the works is to significantly refactor things. This has been kind of a fun proof of concept. Heavy refactoring required. We'll probably end up doing classes. That way we can like wrap a lot of code. Try to maybe I don't know. Um, I think I have the right idea, and it can probably be made very generic. There definitely needs to be some error handling for exchanging messages. Um, I'm not sure why the connection attempts sometimes fail, but maybe the port. I mean, I think the port's open before. Server. So client sends a message, then it opens a port, waiting for that other message to come back from the server. Hmm. Okay, so we actually pass in port to open. Port to open is a randomly selected port. And so we select that ahead of time before we open it. So that's probably what's going on there. The server is connecting faster than we're able to open it. So opening it and then sending the write would probably make more sense. The problem there is we have a race condition, and we would need to be continuously waiting for things while we're able to send things off. So definitely need to restructure this with a threaded model. But this is fun. This is an interesting project to play around with. I wasn't able to get as moving as high speed as I would have preferred to for this session, but I think we got some interesting material rolling here, and I think there would be a lot of people interested to see more VX Underground material kind of manifest here. I'm a big fan of their publications and their tweets, and I like being tangent to the space. While a lot of the code is written from a Windows perspective in the books, I don't see why a lot of it can't be adapted to Linux or, whatever operating system, really. Yeah, I'm losing steam. It's going to be time to get some food here pretty soon. But I'm going to continue to work on this, and probably end up rewriting a fuck ton of this off stream. Just saw Grandma fly across the room at like max speed. She's a little bit restless today, but maybe that's good. She's got energy. But it definitely makes it difficult to get into the headspace. This is one reason I like to code at night. Makes it a little bit easier because I don't have to keep an eye on things as hard. Yeah, we're going to restructure this code to, to do everything that I want it to do. We really have to figure that connection issue out. I think the only way to really solve that problem is going to be with threads. Or to fork a process. I'm not sure what's going to be better, fork or thread. But this is a topic for exploration. No, you don't have a random and funny question. You have a you have a get banned. All right, y'all. Take it easy.